So in this video, you're going to learn, number 1, transforming quadratic functions from standard form to vertex form. Number 2, transforming quadratic functions from vertex form to standard form. Number 3, determining the range of a quadratic function. And number 4, finding the x and y intercepts of a quadratic function. So example number 1. Let us express f of x equals the quantity x minus 5 squared minus 7 in the standard form f of x equals ax squared plus bx plus c. So for our solution, we square x minus 5. So we have x squared minus 2 times the first term x times the second term 5. And then plus the square of the second term 5. And then copy minus 7. Okay, next step we simplify. So we have f of x equals x squared minus 2 times x times 5 is 10x plus 5 squared is 25 minus 7. Next, we add or subtract similar terms. So we have f of x equals x squared minus 10x. Positive 25 minus 7 is positive 18. So the standard form for f of x equals the quantity x minus 5 squared minus 7 is f of x equals x squared minus 10x plus 18. Okay, next example. Express y equals 2 times the quantity x plus 3 squared minus 16 in the standard form f of x equals ax squared plus bx plus c. So again, take note, f of x, that is the same as y. Okay, so for our solution, first, we square x plus 3 before we multiply the product to 2. So we have y equals 2 times, we place the square of x plus 3 inside another grouping symbol. So we have x squared plus 2 times the first term x times the second term 3 plus the square of the second term 3 and then copy minus 16. So we have y equals 2 times, replace the brackets with parentheses because we're now going to simplify the terms inside the brackets. So x squared plus 2 times x times 3. So that's plus 6x plus 3 squared is 9. And then copy negative 16. So we have y equals 2. So we multiply 2 times x squared plus 6x plus 9. So 2 times x squared is 2x squared. 2 times positive 6x is positive 12x. 2 times 9 is positive 18. And then copy negative 16. Next, we combine similar terms. So y equals 2x squared plus 12x. And positive 18 minus 16 is positive 2. So the standard form for y equals 2 times the quantity x plus 3 squared minus 16 is y equals 2x squared plus 12x plus 2. Again, take note, y can be replaced by f of x. Okay, next. What if we are given a quadratic function in standard form and we want to convert to vertex form? So example, express y equals x squared plus 8x plus 9 in the vertex form y equals a times x minus h squared plus k. Then find the vertex. So for our solution, we have y equals x squared plus 8x plus 9. Now here, we're going to add another term so that x squared plus 8x plus the number that we're going to add will be a perfect square trinomial. Okay? But this same number that we're going to add, we also have to subtract so that we're not changing the equation. Okay? So how do we now get this value? We simply divide the numerical coefficient of x, or 8, by 2. So 8 divided by 2 is 4. And then we square. So 4 squared, we have 16. So we added plus 16. So we have to subtract minus 16. Or we have to subtract 16. Next, since x squared plus 8x plus 16 is a perfect square trinomial, we can rewrite that as the square of a binomial. So we have x plus, to get the term here, we just get the square root of 16, which is 4. Or we may just get half of 8, so 8 divided by 2 is also 4. And then we have a positive 9 minus 16, that is negative 7. Okay, so the vertex form for y equals x squared plus 8x plus 9 is y equals the quantity x plus 4 squared minus 7. With vertex at, so if plus 4 here, we have to change the sign, so negative 4. But the k value, we just copy as is, so negative 7. So the vertex is negative 4, negative 7. Okay? So take note, this quadratic function and this quadratic function, they are one and the same. Okay? So they have the same vertex, negative 4, negative 7. Now suppose we want to graph this quadratic function, or this. So let's draw a Cartesian plane and then place the necessary labels. So place y in the y-axis, x in the x-axis, and do not forget 0. And then we place negative 5, negative 5. Alright? So we need a negative 4 in the x-axis. That's why our graph looks like this. Okay? So plot the vertex negative 4, negative 7. So we locate negative 4 in the x-axis. And then the y value is negative 7. So move 7 units downward. So this now, that is the point, negative 4, negative 7. Okay, and this will be the vertex of the graph. Now, we check the value of a. The value of a here is 1. That's positive. And you also have the value of a here, which is also 1. Okay, so since the value of a is positive or greater than 0, so the graph now is opening upward. Okay, so this parabola, that is the graph of y equals x squared plus 8x plus 9, or y equals the quantity x plus 4 squared minus 7. Okay, so another characteristic of the graph or of the function is the range. When we say range, it simply means all possible values for y. Okay, so we use r for range, and then take note in the graph of the function, in the vertex, the k value negative 7, that is the lowest possible value of y. Okay, so we trace negative 7 here to y. So our range now is given by y is greater than or equal to negative 7. So again, for any value we give to x, the smallest possible value for y is negative 7. And then we may write the range in set notation. So we have the set of y such that y is greater than or equal to negative 7. Another example, so let us determine the range of the quadratic function f of x equals negative 2 times the quantity x minus 6 squared plus 19. So again, we graph. So identifying the vertex, we have positive 6. Change the sign here. So from negative 6, take positive 6. And then the key value, so we just get this value, positive 19. So the vertex is 6, 19. And then the range will be, we have y. Take note, the value of a is negative, meaning the graph is opening downwards. And so the vertex, that is the maximum point. So the key value here, that will be the maximum value for y. So the range now, we can write as y is less than or equal to 19. And then write in set notation. Okay? So graphically, let's draw a graph for the function. So again, we locate the vertex 6, 19. So 6 is the x value of the vertex. 19 is the y value of the vertex. So this point, that is the vertex 6, 19. And again, since a is negative, the graph is opening downwards. So as we can see, 19, or the key value, that is the highest possible value for y. Meaning all values of y are from 19 going downwards, or y is less than or equal to 19. Okay, next we proceed to the x and y intercepts. So how do we find the x and y intercepts? Example 1. Find the x-intercepts of the quadratic function y equals x squared plus x minus 6. So to find the x-intercepts, we simply set y equal to 0. So replacing y with 0, we have 0 equals x squared plus x minus 6. So we have 0 equals, we now solve for x, so we factor x squared plus x minus 6. The factors of x squared are x times x. And then we think of two numbers whose product is negative 6 and whose sum is positive 1. Okay, so we now have positive 3 and negative 2. Since positive 3 times negative 2 is negative 6, and positive 3 plus negative 2 is positive 1. X plus 3 we set to 0, and then the other factor x minus 2 we set to 0. Solve for x, so we have x equals negative 3, and we have x equals positive 2. So negative 3 and 2, these are the x-intercepts. Now when we say x-intercepts, these are the points in the x-axis for which the graph is going to cross. Okay? So negative 3 and 2, if we graph this function, it's going to pass through these 2 points. So our answer, the x-intercepts, or another term for x-intercepts are zeros, are negative 3 and 2. How about the y-intercepts? So find the y-intercept of the quadratic function y equals x squared plus x minus 6. Okay, take note, this should only be y-intercept. So to solve for the y-intercept, this time we set x to 0. Okay, so we have y equals, replace x with 0, so we have 0 squared plus 0 minus 6. We simplify, so y equals 0 squared is 0 plus 0 minus 6, and 0 plus 0 minus 6, that is negative 6. So the y-intercept is the point on the y-axis for which the graph is going to cross. Okay, so graphically, negative 3 and 2, those are the x-intercepts, but negative 6, this one is the y-intercept. So the graph is going to pass through negative 6 in the y-axis. So answer, the y-intercept is negative 6.